this opportunity to welcome you to today's lesson. I hope you are going to enjoy a lot from this lesson. But before you start your enjoyment, I'd like you to press the red button there below the video written subscribe. Just press on it, and then you can as well like the video clip. You can as well leave some comments behind for the improvement of the next video clip. Otherwise, feel more welcome to this lesson. This is Mr. Ongeti's Form 3 Mathematics assignment, and this assignment is meant for Kenya secondary schools, and the subject teacher who will take you through the assignment is me, that is Mr. Ongeti Keane Martin. And this assignment, as I've said, is meant for the Form 3s. So just like that, I normally say that when technology is implemented in the classroom, learning is normally brought to reality and students are empowered to create their own learning future. So that's me over there. My mobile number is there, my picture is there, the image, and the main concept here is that the mathematical skill is a necessity in problem solving, as we know that there are so many problems that at times we encounter in our daily life, and most of them, if we have the mathematical skills, then we can solve them. So we have the introduction to the assignment, and this assignment is meant for the Term 1 work 2022, and this holiday assignment will be like our lesson 1, and in each and every lesson we normally have got the objective. So the first objective is that by the end of the lesson, the learner should be able to, 1, work out linear inequality problems, secondly, calculate area of the common regions, thirdly, find the equation of a straight line, and then lastly, solve all the equations in this assignment, which I believe most of you will be able to do that. Okay, we have examples. So in this of our assignment, there are a bit of changes that I'll be taking you through an example. Then after that, then I'll give you a question at the end of the example, which you'll be able to solve as your assignment. So in our first example, we have solve x minus 9 less or equal to negative 4 less than 3x minus 4. Hence, state all the integral values that satisfy the equation. So that's a good question, of course. So what you are going to do before you solve this question is that you are going to break it into parts. So the first part will have x minus 9 less or equal to negative 4. That one will give us the first part. Then the second part begins from negative 4. So you'll take negative 4 less than 3x minus 4. So that one form our second equation. Now, when I begin with the first equation, that is x minus 9 less than or equal to negative 4, I can start by solving it. I'll take negative, that is negative 9 the other side, so as to have negative 4 plus 9, as you can see. Then if you add negative 4 to 9, you'll get 5. On this other side we have x, so it means that the solution for that first equation will be x less or equal to 5. Okay, then we go to the second part of the equation, that is negative 4 less than 3x minus 4. Okay, so I'll begin by solving these. So I'll take negative 4 the other side so as to have positive 4. So I'll have this side as negative 4 plus 4, and then less than 3x. Okay, so negative 4, if you add to 4, you'll get 0 this side, and then less than 3x. Okay, then I can divide both sides by 3. So if I divide both sides by 3, I'll have 0 over 3 less than 3x over 3, which if you divide this side, you'll have 0, which is less than x. Okay, so there we have the two solutions. We have these two solutions. So what I want to do, I want to combine the two solutions. That is x less or equal to 5. I want to combine it with 0 less than x. Now if I combine the two, then we'll have 0 less than x, which is also less or equal to 5. And remember, in our equation we had state all the integral values that satisfy the equation. So we are going to state all the integral values that are going to range from 0 to 5. Okay, so the integral values will be 1, 2, 3, 4, and 5. Why are we saying 5? Because we look at 5 here, we look at the sign, it's less or equal to 5. So it means that it can be a number that is less than 5, that is 1, 2, 3, 4. Okay, and then at the same time it can also be equal to 5. That's why we have included 5. But if it could have just been less than alone, then we could not include 5, because we'll be looking for numbers that are less than 5. Okay, thank you. Now let's look at our assignment. So the assignment for question 1, which I want you to tackle, you can write this one down. Okay, so the question reads, solve the inequalities 4x minus 3 less or equal to 6x minus 1 less 3x plus 8. Hence, state all the integral values that satisfy the equation. Okay, so there is the equation. You can write it down. You can note it down in your exercise book. Then you can start doing it. So I want us to go to example 2. In our example 2, we have this question. Just like that, I say that I'll be giving an example and then I give assignment. So let's look at this example 2, how it's supposed to be done. There the question reads, find the x and y intercept of the equation 2x minus 3y is equal to 6. Okay, so hence find the equation of the perpendicular bisector of the line. Okay, so according to the equation here, we are supposed to get the x and the y intercept of the equation. Okay, and you know that at x intercept y is always 0, and also at y intercept x is always 0. Okay, so we'll substitute that within the equation and we'll be able to get the point. Now once you've got those points, then we are supposed to find the equation of the perpendicular bisector of the line. So this is a perpendicular line that is going to pass at the middle of this line. Okay, let's look at the solution on how we can solve these. The solution there we have at x-intercept y is 0. Of course, I've said that. So if we substitute y is equal to 0 into the equation, instead of having y, we'll have 0. So we'll have 2x minus 3 into bracket 0 is equal to 6. Okay, now there we go. So we'll have 2x is equal to 6. Okay, so we have 2x is equal to 6, of which we can now go ahead and get the value of x by dividing both sides by 2. You divide both sides by 2. We'll have 2x over 2 less than 6 over 2. So this one gives us x to be 3. Okay, so this one, it's x is 3, x is equal to 3. Okay, now this one is not supposed to be less than, not supposed to be less than. Okay, so it's supposed to be equal to 3, not less than. Now let's look at the same at y-intercept. So at y-intercept, we have x is equal to 0. So if x is 0, if we substitute x in the equation where there's x, we put 0. We'll have that 2 times 0, which is 0. So we'll have negative 3y is equal to 6. Of course, y will be equal to negative 2 if you divide both sides by negative 3. Okay, so the points that you're going to have here are 3, 0, and 0, negative 2. Okay, so we can go ahead and get the coordinates of the midpoints. So we have the 2 points, that is 3, 0, and 0, negative 2. And I want to get them, I want to locate the midpoint of these 2 points. So these 2 points are the ones that are going to form the line, the straight line. So if I locate the midpoint of these 2 points, then I can go ahead and use the equation where we normally use x1 plus x2 over 2, y1 plus y2 over 2. Of course, we'll be able to get the midpoint. Okay, there we go. So we can have the coordinates of the midpoint is, so we'll take x1, which is 3, plus x2, which is 0, divide by 2. Okay, then we take again 0 plus negative 2 divide by 2. Okay, 3 plus 0 divided by 2 get 1.5. Then 0 plus negative 2 divided by 2 get negative 1. So the midpoint is 1.1, negative 1. So the gradient of the line L1, okay, we can also look at the gradient of the previous line, which had points 3, 0, and 0, negative 2. So if you want to get the gradient, we know that gradient is always obtained from change in y divided by change in x. So you can decide and take 0, okay, or negative 2 minus 0, which is there. Then you can also take on the x, change in x side, 0 minus 3, which is also there. So this one gives me the gradient as 2 over 3. Now when 2 lines are perpendicular, then we know that the product of their gradient should always give us negative 1, because those 2 lines are perpendicular. Now if you take the gradient, which is 2 over 3, then we'll be able to substitute it here as our first gradient. Then we'll be able to get the m2, which is simply negative 3 over 2. So the equation of the line that is perpendicular and passing at the midpoint, in short, perpendicular bisector, will take y minus 1, which is on the y-axis of the midpoint, and then x minus 1.5 on the x-axis of the midpoint is equal to the gradient, which is negative 3 over 2. And then we form the equation, we cross multiply that, then we form the equation, which will be 2 into y plus 1 is equal to negative 3 into x minus 1.5. So if we solve this one, we'll be able to get 2y is equal to negative 3x plus 4.5 minus 2, which if you write in the form of y is equal to mx plus c, then you'll be able to get y is equal to negative 3 over 2x plus 5 over 4. And that's the answer to that question. Thank you. Now here is the assignment that I want you to take. I want you to note this down. That is for the question 2. And the assignment reads, find the x and y intercept of the equation. 2x minus 4y is equal to 8. Then we have the full stop there. Hence, find the equation of the perpendicular bisector of the line. So this is just an example. It's just the same question. It's almost the same, similar to the question that we've just done. So you can just do that one in your book. You can quickly write it down in your exercise book as the second assignment. Then we can go to example 3. Okay. So in example 3, in question 3, which will be part of your assignment, there are some of the things that you need to note here. And in fact, that's why we have to go through them one on one. Okay. So to reflect an object, for you to reflect an object on the Cartesian plane, you need to draw the same points of the objects, but on the opposite side of the mirror. Then they must also be equidistant from each other. Hence, M becomes the mirror line, which is going to be the line that is going to be in between the object and the image. as you can see here, we have the mirror line, which is at the middle here. Okay, then we have point on an object, which are this point. Let me pick my pen. Okay, so this is the point on an object. Now when it is reflected onto the mirror line, it will appear on this other side. So you realize that the distance between the point on the object and the mirror line is equal to the distance between the image and the point on the mirror line on the other side. That is, the image distance is always equal to the object distance. You can as well see this object here, its image is here. The object, this one, the image is there. The object on that side, its image is here. Okay, we have the object this side, its image is here. And then we also have an object on the this other side, its image is there. So you can see that in each and every time that you want to reflect, you must always consider the image distance to be equal to the object distance, and at the same time, the line that is drawn from the object to the image, it must always be perpendicular to the mirror line at all the time. Okay, and you can see that. Okay, so NB, in our NB, what you're supposed to note here is that to find the mirror line, for you to find the mirror line, you must always join the points on the object and the image together, and then once you've joined them, then you bisect the lines perpendicularly. Okay, so the perpendicular bisector gives us the mirror line. Okay, so below is a diagram in which x-axis is the mirror line. Let's look at the diagram. So I want us to look at the diagram in which the x-axis is the mirror line. So you can see that diagram over there. So in this diagram, you can see a triangle ABC, which is the object, and then we have A prime, B prime, C prime. So our x-axis is our mirror line, meaning that the distance that is taken from the object to the x-axis should be equal to the distance taken from the x-axis to where the image is. You can see point A has been mapped onto A prime, okay, perpendicularly, and also same distance from the mirror line to the image and also to the object. We also have point B on this other side that has been mapped onto B prime. Okay, then we have point C, which has also been mapped into C prime. So therefore, this one tells us that the x-axis is the mirror line. Okay. Now, we can have this as our assignment for question 3. So the assignment reads, the diagram below shows triangle ABC reflected onto its image as shown. State the equation of the mirror line, then reflect the image. Okay, so we are supposed to state the equation of the mirror line, at the same time then we reflect the image. Okay. Okay, so let's look at example 4. In our example 4, we are going to say something about rotation. So to rotate a triangle A through the origin, angle of rotation positive quarter turn. Okay, so for you to rotate that, you first of all draw a line from each point to the center of rotation. In each case, it's the origin. Okay, then measure 90 degrees from the object using a protractor, and then make sure that the baseline of the protractor is on the same line as the line from the point of the object to the center. Then you have to ensure that the zero mark should start from the object. Okay, as you can see here, so we have an angle of rotation which is 90 degrees. So we have A that has been rotated onto B. So you can see there's a point that has been picked here. Okay, so there's a line that is being drawn from the object to the center of rotation, which is now the origin, and then with our protractor we measure 90 degrees until we rotate it to B. Okay, so mark 90 degrees and draw a straight line to the center, joining the lines at the origin. Then the distance from the point of the object to the center should be the same distance as the line you drew. So this gives you the image point. So the distance between the object point and the image point under rotation should be the same as the center of rotation in the case of 90 degrees. And then you can also find center of enlargement in case the object was enlarged. So to find the center of enlargement, what you need to do is that join object point to their corresponding image point and extend the lines. So where they meet gives you the center of enlargement. Or draw lines from each point on the image onto the image through its corresponding point on the object and continue for a little further. Then the point where all the lines cross is what we refer to as the center of enlargement. So you can see that that's an example. So we have this figure here that has been enlarged, okay, to this one. So like, let's say if we wanted to locate the center of enlargement for this and this, then we'll have to take a point like this point and this point, then we draw a straight line. We also take another point, this point and this point, we also draw a straight line. So where these two lines are going to meet, that will give us the center of enlargement. Same to this other one also. You can take some points which are similar, this point and this point, draw the line and extend it. And then this other point and this point, point A, draw a line and extend it. The same point B and B prime, draw a line and extend it. Where they meet, you'll find that they meet at the origin. So that's the center of enlargement. And then we can also have a situation whereby we have triangles that are congruent to each other. So when two triangles are congruent, all their corresponding sides and corresponding angles are always equal, as you all know. So there's always direct congruency and also indirect congruency. So direct congruency occurs when object can fit onto the image directly without turning over. While for the opposite or indirect congruency, you find that you cannot fit onto the image but can fit when the object is turned over. Okay. Now the assignment is there. You can put it down, and it reads: on the Cartesian plane below, triangle PQR has vertices P2, 3, Q1, 2, and R4, 1, while triangle P double prime, Q double prime, and R double prime has vertices P double prime -2, 3, Q double prime -1, 2, and R double prime -4, 1. So you can see those two triangles. So we have PQR, we have P double prime, Q double prime, and R double prime. Okay, so you can draw that and then have your graph where you can plot the two triangles. You can pause the video and then plot the two triangles. Then the question are as follows. Okay, the first question: describe fully a single transformation which maps triangle PQR onto triangle P double prime, Q double prime, and R double prime. That's the first part. Then the second part, part B: on the same plane, draw triangle P prime, Q prime, R prime, which is now the image of triangle PQR under reflection in the line y is equal to -x. Okay, part C: describe fully a single transformation which maps triangle P prime, Q prime, R prime onto triangle P double prime, Q double prime, and R double prime. You can include that. This one is double prime here. Okay. And then we have part D. So in part D we have draw triangle P double prime, Q double prime, R double prime such that it can be mapped onto triangle PQR by a positive quarter turn about 0, 0. And then lastly, part E: state all pairs of triangles that are oppositely congruent. So you can go ahead and state the triangles that are oppositely congruent. So you can pause the video and put down those questions into your exercise book. There we have example on SOHCAHTOA. And now example, we have a triangle which is a right angle triangle with the hypotenuse, the opposite, the adjacent, and angle x. Okay, so we have sine. So sine theta, which is this one, is equivalent to b over c. B over c, that is opposite over hypotenuse. Okay, then we have cosine theta, which is also equal to adjacent, which is a, over c, which is the hypotenuse. Then we have tan theta, which is opposite over adjacent, which is b over a. And then tan theta is also equivalent to sine theta over cos of theta. Okay, then we have cot theta, which is the reciprocal of tan theta, which is cos theta over sine theta. We normally call it cot theta, though there are some that we'll cover later on at the higher level of learning. Then we have secant, which is sec theta is the same as 1 over cos theta. We have cosecant, which is equivalent to 1 over sine of theta. So if tan theta is equal to 8 over 15, okay, find the values of sine theta minus cos theta over cos theta plus sine of theta. And here you are required to find the values without using a calculator or a mathematical table. So let's take an example of this triangle. So if we have this as our triangle, then we can draw the triangle and also use whatever we are given, that is tan theta, to be equal to 8 over 15. So it means that our opposite is 8 to the angle, and then our adjacent is 15, which gives us tan theta. So if we replace that, we can go ahead and get the hypotenuse. And we get the hypotenuse by simply squaring 15 squared plus 8 squared. Then you sum them and get the square root, you get 17. Okay, so from there we'll be able now to get these values. So on the upper side, we have, on the numerator, we have sine theta, and sine theta is equivalent to opposite over hypotenuse. So the opposite is 8 over 17. And then cos theta is adjacent over hypotenuse. So that will give us 15 over 17. Okay, so if we replace it into the equation, we'll have 8 over 17 minus 15 over 17. Okay, then on the lower side, which is the denominator side, we'll have 15 over 17 plus 8 over 17. So if we work out this, we'll get negative 7 over 23. Let's look at our assignment for question number 5. So in question number 5, you can put down that if tan theta is equal to 24 over 45, find, without using tables or calculator, the value of tan theta minus cos theta, everything divided by cos theta plus sine of theta. So let's move to example 6. So in example 6, we are going to look at area of a segment of a circle, and we'll start by defining what a segment of a circle is. So a segment is a region of a circle that is bounded by a chord and an arc. So the region that is going to be bounded by a chord and an arc, we refer to it as a segment. Like for example, the shaded region here is bounded by an arc AB and also a chord AB. So that shaded region gives us what is called a segment. So in the figure above that we have just seen, the shaded region is a segment of a circle with center O and radius R. So AB is equal to 8 centimeters, ON is 3 centimeters, and then we have angle AOB, which is 106.3 degrees. Now we are supposed to find the area of the shaded part, that is the area of the segment. So we look at the solution. So now for us to get the area of the segment, we'll take the area of the sector, which is OAPB, minus area of the triangle, which is OAB. So that will be 106.3 over 360 times 3.142 times 5 squared, then minus half 8 times 3, which is area of a triangle. And then after that, when you work out this, you'll be able to get the area of the segment, which is 11.19 centimeters, square centimeters. So you can see that. So what I've just said is that you take the angle here, which is 106.3 over 360, and then multiply with the pi, which is 3.142, and then after multiplying with pi, okay, after multiplying it with the pi, we multiply with the radius, which is 5. So 5 squared, then minus the area of this triangle here. Remember, we have the base of the triangle as 8 centimeters. We have the height, which is 3 centimeters. So you'll take a half times 8 times 3. Okay, you get 12. Okay, then we'll also have the area of the sector, which is theta over 360 times pi r squared. So if you work out this, you get 23.19 minus 12. Then you get 11.19 square centimeters as our answer. Thank you. Now, assignment for that question 6. So you can write this down. In the figure above, the shaded region is a segment of a circle with center O and radius R. Change the following values and take AB to be 12 centimeters, radius to be 10 centimeters. Then find the area of the shaded part. So I want you to use the same figure that you had seen previously. And then in that figure, I want you to replace AB with 12 centimeters, radius with 10 centimeters, and then the hint, use Sokatoa so as to get the angle AOB. Once you got the angle, then there you go. You can go ahead and get the area of the sector, then subtract the area of the triangle. And that's the assignment for question number 6. So it will be much easier for you to do because I've already given you a hint on how you are going to do it. So let's look at example 7, which will give us question 7. In example 7, the area of a common region between two intersecting circles. That's the examples. So you can see these are two circles, and then there's this region where we have two circles are intersecting. So I want us to look at how we can get the area of the shaded region. So that is the sector. Now find the area of the intersecting circle above if the common chord AB is 9 centimeters. So we have a common chord which is AB. Is common to this circle and also to this other one. So it is 9 centimeters. Now if I want to find the area of the intersecting circle, I'll start by getting the angle. I'll start by getting not the angle but the distance O1M. This distance here. Because I know that from here to here is 9, then half of 9 is 4.5. And I have the hypotenuse here to be 8. So 8 squared minus 4.5 squared, I'll be able to get O1M. Okay, so if you square that, you get the square root, you'll get O1M to be 6.614 centimeters. Then from triangle O2M, okay, this triangle, I also have 6, I have 4.5, I can get O2M. So that is O2M, not O1M. O2M, which will be 6 squared minus 4.5 squared. Okay, so this one is O2M. O2M. Okay. Yes. Of course, if you work out that, we'll have 15.75, which if you get the square root, you get 3.969. So we have this distance here, O2M. Then the area between the intersecting circle is the sum of the areas of the segments. So we are going to get the segment AP1B and AP2B. Then we'll be done with that. Now let's look at how we can obtain the area of the segments. So area of the segment AP1B is equal to area of O2 O2A P1, this one, O2A P1 B, which is area of the sector, minus area of the triangle O2A B. Okay, then we'll be having our area of the segment. Okay, so using trigonometric ratio, we can get the angle. So if you find that angle, you'll be able to get 48.59, which is this angle over there. And then because we have both the upper and the lower angle, you multiply by 2, you get 97.18. So for you to get the area of the segment, you'll get theta over 360 pi r squared minus area of the triangle. So you'll get 97.18 over 360 times 3.142 times 6 squared minus a half times 9 times 3.969, which if you press in your calculator, you'll be able to get 30.53 minus 17.86, which is equivalent to 12.67. So that one gives us this area, this side. Now I'm remaining with the area on the other side, the area of this other segment, that is A P2B. So we also do the same. We first of all get the angle using sine, so which is opposite 4.5 over 8. Then you get the sine inverse, then you multiply by 2 the angle so as to get the whole angle here, which is 68.46. Now you take 68.46 over 360 times 3.142 times the radius, which is 8 here, 8 here, so 8 squared, then minus area of this triangle. We know that the distance AB is 9, and we have this distance here, which we had previously got to be 6.614. So if you multiply that, then you subtract from the area of the sector, you'll be able to get 38.24 minus 29.76, which is equivalent to 8.48 square centimeters as our answer. So if you want to get the total area for the common region, you add the two. So you'll get 12.67 plus 8.48, which will give you 21.15 square centimeters. The assignment is that we have two circles of radius 13 centimeters and 16 centimeters. They intersect such that they share a common chord AB of length 20 centimeters. Calculate the area of the shaded part. Take pi to be 22 over 7. Okay, that is 10 marks. So in short, what I want you to get, the area of the common region that is shared by these two circles. Just the same examples, but with different radius and different length of the common chord, which is 20 centimeters. So you can go ahead and write that one and quickly do it. Okay, you can do it in your exercise book. It's very simple, being that I've already given you a hint from the example. You can tackle that. There is the question. Example 8. Example 8 is under translations and vectors. So the translation at the left shows a vector translating the top of a triangle 4 units to the right and 9 units downwards. Okay, the notation for such vector movement may be written as, so 4 units to the right, which is on the positive, and then we have 9 units, which is towards the negative downwards. And you can see that vector. You can see the triangle that has been translated downwards. Okay, so it has been translated from where the object is to the image. So this is a translation, and the translation vector has been given here as 4, -9. So when you're translating, always we add the translation vector to the coordinate of the object, then you get the image. Like we look at this coordinate here, okay, we have -6, -6, 1. So -6, 1, if you add it to this, you'll get this coordinate point, which is -2, -8. The same you'll do to this at the rest of the point, then you'll end up having your image at this point. Okay. So vectors such as those used in translation are what is known as free vectors. So we normally refer to them as free vectors. So we write the magnitude of u as this. This is the symbol for the magnitude of u. Okay, so if I want to get u, and you see u is given as xy, and I want to get its magnitude, then for me to get the magnitude of u, I'll square x squared plus y squared. Okay, so you square those two, you get the square root of the sum of the squares, then you'll be able to get the magnitude. Now assignment on these. So assignment for question number 8. So the assignment reads, there it is, you can note it down, that the point A, negative 4, 4, B, negative 2, 3, C, negative 4, 1, and D, negative 5, 3 are vertices of a equilateral. So if the equilateral is given the translation T defined by the vector, or let me rub this, okay. So the vector that has been defined is 3, 1. Oh, this is very, very easy. So it means I can get the images by simply adding this translation vector to the coordinates. Okay, so if you add this to this, you add to B, you add to that, then you get A prime, B prime, C prime, D prime, then you go ahead and plot it. Then you'll be able to get the image. Okay. So plot the object and its image on a Cartesian plane. You can go ahead and do that. Then lastly, you can find the magnitude of the vector T. So the magnitude of this, remember I'd shown you how to get the magnitude here. So you should be able to get the magnitude there in your assignment. Don't fail to get that. Example 9. In our example 9, we have a positive 2-digit number is such that the product of the digit is 24. When the digits are reversed, the number formed is greater than the original number by 18. Find the number. Oh, very easy. Let's look at how we can handle that. So the solution to this is that let the ones digit of the number be y and the tens digit be x. So the number will be x, y. Okay, so x, y, those are the digits, which is, if you multiply the digits x times y, you get 24. That gives us, serves us with our equation 1. Now when the number is reversed, the ones digit is x and the tens digits become y. So therefore, in terms of values, we know that the ones has a value of 1 and the tens has that value of 10. So if you want to get the total value, you simply multiply by the number within the digit. So like for example, yx has the value of 10y plus x. Now when it is reversed, it now becomes 10x plus y. So if we put them in bracket and then we subtract, then you will find that the final number exceeds the original one by 18, and thus give us our equation 2. So if we simplify this, we'll have y minus x is equal to 2. So I wanted to solve these two equations. So we have y is equal to 2 plus x. So if we substitute into the equation, because already we form y as the subject, 2 plus x, so that where this y we put 2 plus x, we'll get 2x plus x squared is equal to 24, which gives us a quadratic equation that we can go ahead and solve. So this quadratic equation can be solved as x squared minus 4x. Then we look for two numbers whose product will give us negative 24 and sum will give us 2. That's none other than negative 4 and 6. So this one will break this 2x into negative 4x plus 6x to enable us factorize by grouping. Okay, so if you factor this by grouping method, so we'll have x into x minus 4 plus 6 in x minus 4 is equal to 0. So because this side we have x minus 4, you can pick one and then take x plus 6 is equal to 0. So this one means that the number can either be negative 6 or x is equal to 4. But we look at our equation. In our equation we had a positive 2-digit number, meaning that the digits are not negative. They are all positive. So we'll go for x is equal to 4 instead of x is equal to negative 6. So we'll drop it. We'll drop x is equal to negative 6 and pick or take x is equal to 4. So since positive, x is equal to 4. So that now we can get y, and from here we had already formed the value of y, which is equal to 2 plus x. So when you substitute it there, hence the number now becomes 46. And you can as well prove this. In fact, these are questions that you should not fail, because you can as well confirm 46. If it is reversed, it becomes 64. Now 64 minus 46, you get 18. You can see it exceeds the original one by 18. So let's look at our assignment for question 9. Assignment for question 9 reads: a positive 2-digit number is such that the product of its digit is 36. When the digits are reversed, the number formed is greater than the original number by 45. Find the number. Oh, that's now easy. Now you can try that. So let's look at our example 10. So example 10 is all about a quadratic graph, where you are required to draw a graph of y is equal to x squared minus 7x minus 2 is equal to 0. So I can get my values of y using my calculator. So in my calculator, I can take the values of x to be 0, 1, 2, 3, 5, and 7. Okay. Then I start by pressing in my calculator. You can press this. You can press bracket 0, close the bracket, squared, minus 7, open the bracket, 0, close the bracket, minus 2. So once you've pressed that in your calculator, we'll be changing the values using the replay on the calculator. There's a place there written replay, the big one. So that's what we'll be changing. So there's no need for you to keep on pressing again and again and again. It's a very short method, especially when you see in mathematics we are competing with time. Okay, now for 0 you'll be able to get 2. Then using your replay, change zeros to 1, you'll get negative 4. With your replay, change 1 to 2, you'll get negative 8. With your replay, change 2 to 3, you'll get negative 10. With your replay, change 3 to 5, you'll be able to get negative 8. With your replay, change 5 to 7, you'll be able to get 2. So there are the values for y and the values for x. We can now go ahead and draw a graph. So you'll have your x-axis and the y-axis downwards. Okay. Now you can plot and then draw a smooth curve. So I want you to draw a smooth curve like the one that I've just drawn. This is a very smooth curve. Okay. Without sharp points. Okay. Now, the assignment for question number 10. Complete the table below for the function y is equal to 2x squared plus 4x minus 3. So, I've already filled in some values for you. So, you can go ahead and fill in. So, the values of x are there. 2x squared. So, this is a bit different. So, you'll be able to say 2 times negative 4 squared. You get 32. 2 times negative 3. You put in bracket, bracket negative 3, close the bracket, squared. Don't just put 2 times negative 3 squared. It will be different values. Ensure that you put bracket within the negative numbers. Okay. Then you can also have 4x minus 3. That is 4 times negative 4 minus 3. That one you can just put direct, and then you fill in. Then you can now go ahead and get the values of y. Now when you're getting the values of y here, ensure that you don't add the ones on the x side. So you start adding from 2x squared. Add this, that, this, okay? These ones, the ones that I'm pointing. Then once you've added that one, then you'll be able to get the values of y. Then on the grid that you can have, you just get a graph paper somewhere. Then draw the graph of the function y is equal to 2x squared plus 4x minus 3. And the range here is what is already in the table. from -4 up to 2. So this range tells us that we are supposed to take our values of x ranging from -4 up to 2. So that is -4, -3, -2, -1, 0, 1, 2. And then use the graph to estimate the roots of the equation. 2x squared plus 4x minus 3 is equal to 0 to one decimal place. Then part C, in order to solve graphically the equation 2x squared plus x minus 5 is equal to 0, okay, a straight line must be drawn to intersect the curve y is equal to 2x squared plus 4x minus 3. So I want you to use the graph which you have drawn to solve this equation here, 2x squared plus x minus 5. So the hint that you have been given here is that you have to ensure that you draw a straight line, okay, that will intersect the curve y is equal to 2x squared plus 4x minus 3. Then determine the equation of this straight line, okay, then draw the straight line, hence obtain the roots 2x squared plus x minus 5 to one decimal place. So the roots will be obtained from where that line is going to cross the quadratic curve that you had previously drawn. So that one you can go ahead and do. Okay, learners, I hope you enjoyed the lesson, and most of the concepts that were being explained, you are in a position to understand them. Now, before you leave the video clip, I would like you to press on the red button below the video clip, written subscribe. Just press on that. You can as well go ahead and make some comments, and at the same time like. There's a place there written like. You can like the video clip. Otherwise, may I take this opportunity to welcome you in the next coming videos.